Welcome, Ramazan. Welcome, Alan. Welcome, Benjamin. Nice to see you again. Welcome, Don, Germano, Jerry, Joseph. Welcome, Larry. Long time no see. Welcome, Lee, Max, Nir.
We also have Robert Schulze, who many of you may know from ClickHouse performance fame. We also have Song-Yeon-son from Korea. It's 1 a.m. in South Korea. Song-Yeon, I'm in Japan at the moment, so it's also 1 a.m. for me in Japan. Um, Mark is presently putting us live on YouTube, and we'll share the link shortly in chat. One thing to mention is chat is live. Please feel free to use it, but also the Q&A functionality is live as well. So if you have a question, flag it there. We'll do our best to address all of the questions at the end. It always, of course, depends on time. But we'll also be streaming this to YouTube. So if a friend of yours has made the choice not to register to join us on Zoom, pity for them. But also, they'll be able to see it on YouTube. So when that's live, Mark will post it in chat.
Yeah, so the link's there. And then usually what we do on these, at some point, Alexei will show us a query that's been made faster.
I'll be
And we're
streaming
gonna,
this to
we want
YouTube.
to,
So if
Yeah,
hang
Tyler,
on.
please. You said something.
Yeah, so I was going to say, so at
Yes.
some point, you have to try and beat me at guessing how quick the query is going to be. And whoever wins, Tyler will contact you and you'll get some sort of ClickHouse merchandise. Tyler got to decide what it'll be.
Yeah, indeed. I have socks and I have shirts available, and my apologies for that. My AirPods were lost in an airport 2 flights ago. So as I was opening up the YouTube link to share it with others, it started playing and my mic was live. So my bad on that.
Ah, that's what happened. I was trying to work out. It's like,
Yeah,
makes
hence the
sense.
like 12-second delay that makes everything confusing.
Cool. Well, I mean, it's a few minutes past, so I guess should we start, Alexia? Hide myself
Let's
and let you.
start.
If you could give me 30 seconds, that'd be great. I just want to share it on YouTube, on X, on LinkedIn, and on Slack and Telegram. Speaking of
Okay.
which, if you haven't joined us, clickhouse.com/Slack. I see ones and hundreds. Let me know other places that you're from. Give me just 2 minutes, Alexei, and then you can kick off.
Okay. We have so many features and so many people joining. Interesting, what is the most distant place? Because I see people from London, from New York, South Korea.
South Korea must be the furthest from us.
I don't know, maybe Australia. Anyone from Australia?
Anyone from Australia still awake? 3 a.m. or something.
It's not an excuse.
Join the ClickHouse Christmas party at 3 a.m.
Yeah, a lot of Christmas gifts waiting for you.
Cool, I think. You want to share your screen then, Alexia, and we can do this. And I can see it.
Yeah, indeed. I've shared in all the places. For those of you who got a DM from me inviting you to this call, thank you so much for being here. Many of you told me that it would be 2 or 3 a.m. where you are, but you would join the call anyway because you're so excited about what's in 25.12, and mostly because you want to beat Mark as it relates to guessing query performance. So, Alexei, please take it away.
So this is ClickHouse release 25.12. This is our Christmas release, and we have a lot of interesting features. I would say gifts for you, because today it's not just about feature, it's about gifts. And we'll have a guest talk from a real Santa. I will introduce him later. But I don't know, maybe you will just confuse me or Tyler as a Santa. It's also okay. And hopefully a few minutes for your questions. So the release has 26 new features. 31 performance optimizations, and a whole lot of bug fixes. And let's start with some small and nice features, some small treats. And as usual, a new function. We have a lot of functions in ClickHouse, like 1,000, maybe 1,500. So why don't have even more? And the new one is named HMAC. It is hash-based message authentication code. It takes an algorithm. In this case, it is SHA-256. It takes a string and it takes a secret key. And it hashes this string cryptographically using the secret key. And the intention is to prove authenticity of a string using a shared key. For example, if there is an API, you hash a message and server checks if the message is authentic. Or if there is a webhook, so you ask a server to send some events to you back, you can check the authenticity of this server. For example, you can set up a webhook from GitHub, and GitHub will send events directly to ClickHouse, and you can validate that all of these events are coming from GitHub. In this example, ClickHouse server itself can provide this webhook with insert query, and you just check that everything is correct from the HTTP header. You take an HTTP header, you take a message, hash it, and check if it equals. Before that, it was also not a big problem, but you had to specify and allow a list of IP addresses. You had to know which servers to trust. Now you can just validate. Sounds nice? Let's take a look at the next nice function. A new function for dictionaries. But first, let me remind you what the dictionaries are. I hope you are all like seasonal ClickHouse users. You already know what the dictionaries are, but just in case. Dictionaries are like tables for very fast optimized key value lookups using specialized data structures. It can use like a hash table in memory for a lookup, but also it can use something advanced like a tree of IP ranges to find some properties of IP addresses, or regular expression trees that will apply different regular expression to, say, parse a certain string like a user agent. Or polygonal dictionaries, it's also a nice feature. You just record the properties of any places on Earth and do reverse lookups. So you have coordinates, you find a polygon, and you find certain attributes. All of this is possible with dictionaries, and they can use many different data sources like external HTTP server or Redis, Cassandra, MySQL, ClickHouse tables, anything. And in this example, I created a dictionary that converts ID, location ID, to borrow zone in New York. And the usage is simple. Select did get. It looks like a function that will do this lookup. For example, convert the identifier to borrow, which is Brooklyn. And the new function is named dict get keys. And what it does a reverse lookup. So instead of key value lookup, it takes a value and returns an array of keys. So if we invoke it this way, select dict get keys, the dictionary name, the attribute name borrow, and the value. In this example, it is constant. Obviously, it's in practical usages, it is not constant. And it will return an array. And in this case, it is just a single element because there is a single Brooklyn. I don't know, maybe there is another Brooklyn, maybe there is there are like 10 or 100 Brooklyns in the United States, but in New York, it's only one. And it is quite well optimized, so it will not do like full scan, it will create a cache. So bulk lookups will be automatically optimized. Okay, it was about functions, we had just two. And now about compatibility. And the first feature is support for non-constant lists inside the right-hand side of the in operator. Let's take a look. Here we have a query, and we have a filter on search phrase with explicitly defined list of constants. And it works, it always worked, nothing surprising. You can also substitute a table in the right-hand side, and it works in the same way as if you write subquery. And it also always worked. The subquery is run, it generates this list in memory. It even is even converted to a hash table for optimal lookups. But before 25.12, if you write an explicit list, but not with constant expressions, with some dynamic expressions, or the whole list can be also dynamic. Like in this example, we have two constants and another expression depending on a column. It did not work. It said the list has to be a constant or a table expression. Now it works. So I don't even know how to show you this feature. Let's put it simply. Everything works. Okay, and the next feature, it's about just a small thing for usability. So ClickHouse supports alias columns and materialized columns, which can be defined to arbitrary expressions. And in the case of alias columns, now we have two aliases in this table, and one contains this not so complex expression, and another alias is trivial. It just defines that the referer column, which is here, can be accessed by another name, referrer, which sounds more correct, but the HTTP standard defines referrer with single R here, and it is different. Interesting what will happen if you ask ChatGPT to count R's in referrer. Will it say one or two, or just confuse it with strawberry? I don't know. What's new in 25.12? Now it is possible to use aliases if they are trivial, not only in select queries, but also in insert queries. So you can use this as a regular column for insertion. Sounds easy, nice, and now we have it. And the next one is a small improvement for projections. For some of you, it does not mean anything, but if you use projections, especially aggregate projections, sometimes you might want to define different settings controlling like how physical data will be organized for a projection to be different than the settings for a table. In this example, we have a table, and for a table, you can, as usual, define certain settings here, like index granularity. But in this example, we define a projection, and projection has a custom set of settings. And this makes sense for aggregating projections. In this example, certain aggregate functions can be quite large, like this aggregate function unique. and specifying just a little bit lower index granularity will make lookups more efficient inside this projection. It also supported for alter queries, so you can do like alter projection and just specify new settings. What else? And another one, an improvement for secondary indexes. What is the difference? Before version 25.12, in previous versions, if you defined an index on a certain column, like in this example, it's a min-max index on a column X, then you cannot modify this column using alter. If you do this alter, ClickHouse will just tell you that it cannot alter a column that is part of the index. But now, since 25.12, it just works. And it will be often the pattern of 25.12. Everything works perfectly. And you can even tune it with the different modes. And the modes are like you can just forbid it if you want the previous behavior. You can ask it to invalidate the index at the moment of alter, so it will not touch the index, it will just drop it. You can later calculate index again with the materialize index query, or rebuild this index, and rebuild is the default option. Okay, even more small and nice features for you. Now about S3Q. So to remind, S3Q as a table engine that subscribes to a bucket with a set of files, set of blobs. You specify a wildcard pattern like in this example, and it will constantly monitor for new files in the bucket and process them. So you can define a materialized view on this table, and this table will process files, send them to the materialized view, which can process these files any way you want. And the new in 25.12 is a new mode, what to do with the files after they are processed. So before we only used to have two different modes. You could keep the files. So the table will just remember which files are processed, which files are not. Or delete files. So you don't need the files anymore. They are processed. They will be deleted from S3. Now we have way more of flexibility. Two more options. One option is move. You specify a prefix where to move these files, blobs, or you specify even a different bucket. So you can define a queue, it will process files, and it will move them supposedly in an optimal way. It will take some effort, but it will move it to a different bucket. You can even specify different credentials for a different bucket, so it is quite flexible. Or you can attach a tag on a file. You specify the key value, and it will just tag it. These tags can be later queried by ClickHouse or by other systems. And obviously, you can create multiple different S3 queues on the same data source, or you can define a single S3 queue and multiple materialized views. Oh, even more. A new output and input format. Name it buffers. So what it is for? It's a format similar to native and arrow column-oriented format, quite efficient. but it is bare bones. It does not have any metadata. It does not have any headers. It is not really safe to use. You have to actually know what you want to read and what the server will provide you, which data types, which column types. But the only purpose is for serializing into memory. Serializing inside shared memory, interrupt with WebAssembly. And yes, we created this format mostly not for you, but for us. Mostly for WebAssembly. And I am not going to tell you why do we need interacting with WebAssembly. It could probably be a story of the next presentation, but now we just have this input and output format, and you can use it. It's pretty simple. An integer with the number of columns, an integer with the number of records, buffer size, also 64-bit, the data for the first column, again buffer size, and the data for the second column. It's pretty easy. Okay, now about performance improvements. And we have a huge number of improvements. And let's dig in. What do we have? The first one is about parallel replicas. You know that parallel replicas is a way to make a query distributed using the resources of not just shards, but replicas. So the replicas contain identical data, and you run a query, and the server will fan out. It will send this query to other replicas, and these replicas will ask to take some work to do. And different replicas will process different ranges of data, so the query will be parallelized and speed up. And what is particularly new in 25.12? Let's look at this comparison. So the question, it's quite a simple question, but does it actually make sense to parallelize a query across many replicas? Sometimes there is a lot of sense if this query takes a lot of time, like it took 10 seconds, you use 10 replicas, and now it takes 1 second. It's a huge difference and it makes sense, but it's a question if a query takes like 10 milliseconds. You send it to 100 replicas and now it takes not 10 milliseconds, but like 50 milliseconds, which does not make sense. And it doesn't make sense if you have a lot of concurrent queries and your cluster will be overloaded by all of these small sub-requests. It also does not make sense if a query takes a lot of time, but also transfers a lot of data over network. So the difference is, in the new version, the selection when we should use parallelism, when we should not, is automatic. And we can see that with this automatic selection, and actually even by default without this automatic selection, but just in the new ClickHouse version, on average and on the vast majority of queries, even small queries, enabling parallel replicas improves the performance. So now you can just enable them and enjoy the speedups. Okay, the next feature that I will probably need to demonstrate is quite powerful performance optimization. Data skipping during sorting. So let's suppose we have a query, it reads some data, sorts by a column, and extracts the top. It's not a surprise, we already used to process it in the following way. We read the data in multiple threads in a streaming fashion. We do partial sorting and maintain just top 100 of records in memory. So it's not a surprise. And we already had a lot of optimizations for it, like lazy reading, reading in the order of table key. Everything worked. What's new in the Christmas release? Now we also incrementally maintain what is the lower boundary of this set of 100 entries. Like what is the bottom record of the top 100? And every time we read the next part of the data, next granular of the data, we use this boundary value as a filter. And it can be used as a filter using efficient preware, or even it can use data skipping indexes. It is controlled by a few settings. They are currently not by default. It's a new optimization, so they will be by default probably in the next version. But you can already enable them for your queries. Let me show some demo, because it is going to be interesting and it is going to be a guessing game. And if you guess correctly, I will give something nice to you. Mark, do you know if we have some winter swag?
Winter swag. Oh, I don't know. We have to ask Tyler. He said he's got socks. ClickHouse socks.
Okay.
For the
I don't
best
know.
for the best answer, I will make something special happen.
Oh, that's interesting.
Christmas swag.
Now I want to win this game, because I
Yeah, even more
definitely need this.
incentive now.
Yeah. Okay, so let's run a query. This is pretty simple, but it uses a table with page views from ClickBench and filters by URLs, just in case. And then extracts the first 10 records by time. Let's run it. Let's run it again. So it took 120, 111 milliseconds, and it is fast. Yes, it is fast, most of the time. Now let's enable the first setting. And Mark,
All right.
let's first give a chance for the audience to guess. How
Okay,
much?
so Alex says 24, Deepak 11, Joseph 40, Christopher 0.09, I'm guessing 9, 26, 10. You can't give answers less. These are like in seconds. We've got 5 milliseconds, 10 milliseconds, 42, 20, 1, 0. Tillman is
I
like
like this.
very wow. There's so many answers. 1, 10, 2. Okay, I think I'm gonna say 50.
Oh, interesting.
All right,
50.
let's do it. 55. Who's the closest? I think someone said 60 though.
Let's resolve this question. So
66,
50.
50.
So now, Mark,
Joseph said 40.
okay, maybe if we run it multiple
Herb
times, it will
said
be 40.
70. What do you think?
This is
Yeah, I think
production
Joseph
standard.
wins. Joseph's the closest on 40. Send Tyler a message. Tyler, what is it? Tyler at clickhouse.com. Is that where we need to go?
Indeed, Tyler at
Hang
clickhouse.com.
on.
Joseph, I will
I'll just
make
write it
you
down
a
for you,
happy
Joseph, and
man
you
for
can just send
Christmas.
him a message. Say, I beat everybody.
So just a single setting. And now the query is 2 times faster. But the
Nice.
question is, can we make it even faster? And if we can, how? Mark, this is a question for you, and it is pretty simple question. Can we make it even faster?
I'm guessing the answer must be yes.
Mhm.
That's
And
how the
now the
game
question,
works.
the question is how.
with another setting.
Yeah, absolutely, using another setting. But not so easy. So
Okay, not another setting.
for another setting, we will create an index on this column of type min max. And we did not have an index, but I probably created it before this call. So now we have it. If you create this index from scratch, you also typically materialize this index. So it will be physically created in data parts. And
So did it already use the index?
let me explain. We can see that the index is definitely materialized if we take a look in the system mutations table. So now what we are going to do is to enable not only the previous setting, but also another setting. Use skip indexes on data read and use skip indexes for top k. The previous one was use top k dynamic filtering, and it worked without any index. The new one will use the index. Okay, and now the same question. How much faster will it be?
All right, give me the answer in milliseconds. It's easier to read. Okay, Jesse says 35. Ruben says 10. What else? We got 30, 24, 8, 5, 2, 55. Alex says, why don't you just have it working with those settings by default?
This setting will be by default. Probably in the next release. Typically, we do it like in 2 steps. In one release, we introduce these settings and let you turn them on manually. In the next release, we just enable them by default.
Okay, we've got 3 people who said 10, we've got 12, 4, 25, 21. We've basically got every number. So
Okay, we cannot
let's
lose.
see.
And Mark, what is your answer?
I'll say 25.
Okay, let's take a look. 28.
Okay, 28.
How
Second
did you
time,
guess?
27.
So who beats Mark?
28. Come on, somebody must be.
That was our
Well,
promotion.
Larry's on
Who beats Mark?
25.
You know, we
So what's the
also
average? 28. Well, David's better than me.
have
24.
ClickHouse benchmark. Maybe we can run a
So
ClickHouse benchmark.
I'm not sure how you say your name. Soy. No, I can't be. This is surely going to be wrong. Soingon 30. I think that's the closest.
Let's take a look with ClickHouse benchmark. So the first invocation was without any settings, and with these nice settings, let me just copy paste them. Let me copy paste 3 different settings. And we will find the most precise, the best answer. 23 is the minimum, and the median is 26. Among 300 invocations, 26. Okay, that was a nice optimization, but I have even more for you. Faster lazy reading. I already told that this order by queries can be also optimized with lazy reading, which is, by the way, by default. But in the release 25.12, we optimized it even more. And again, I have to show you a demo. And now I will show it on my workstation. And first I will run the previous version of the server. It's here, 25.11 server. It starts up. And here I will run ClickHouse client. Okay,
Are
here
all
it
of
is.
these optimizations like extensions on the laser materialization that ClickHouse started doing in April? Or are they completely different?
When we introduced laser materialization, I was surprised at how much it actually improves performance, but now I'm surprised even more. Because let me show you. So we have this query that also orders by event time, and it will read 100,000 of top records. And we have a certain threshold that limits the application of laser materialization. And typically this threshold is quite low. But the point is, in the new version, we can set it to unlimited. This setting will basically tell that there is no limit. It will use laser materialization. And now keep in mind, this is version 25.11, so the previous version without optimization. Let me run this query just to see how long it will go. Okay, it runs. It quickly read all 100 million records, but now it tries to do this 100,000 of lazy reads of the remaining column. So on the first pass, it read event time, located the top 100,000 of records, and now it has to read all the rest. And it took 31 seconds. I cannot say it is fast. It isn't. Because we have to compare now with the new release, Christmas release, the best release ever. And here is ClickHouse built today. That will be in the release. And let me run the same query. And now again, should we ask all the audience or maybe just Mark? Maybe Tyler?
All right, just me and Tyler. Test one. So what? So before it was 31 seconds?
Mm-hmm.
I don't know. So what do we have now that we?
If it's not in the range of 10 seconds, a 3x improvement, I'll be surprised.
Mm-hmm. Yeah, I will be sad if it will not be like 3 times better, maybe 5 times better, but let's figure out. It took
Less than 1.
less than 1 second, 0.7. So it
And this
is
is with the max limit optimization turned off.
no limit. So it will do lazy reading for all 100,000 of records.
Okay.
So it is 50 something times faster, if I calculated correctly. Yeah, probably it is the most powerful optimization, thanks to Nikolai Kochitov.
Will this, Alexa, will this be set to unlimited by default?
It is already by default, so you install 25.12 and you get this improvement. Okay, we have so many optimizations, and now one more about skip indexes. In the Christmas release, we are able to get use of skip indexes even if they are mixed inside complex conditions with and or chains, even for different indexes. Like in this example, we have an index on v1, index on v2, and all of them are mixed together, and we can use all these conditions at once. We just calculate a bitmap during query analysis, and it works. Before that, only primary key was so magical. Now all of index types will benefit from these conditions. And yet another optimization, in-place filtering. It's a low-level optimization. Low-level optimization for cache locality, for avoiding extra memory allocations during filtering like where or pre-where. Let me quickly demonstrate it. I have a few examples. This is low-level, so the examples are going to be also quite low-level. And again, let me run the previous server version. Here it is. And I will use ClickHouse benchmark with this query that calculates something from a search phrase, but first reads and filters this search phrase, and the filter filters out a lot of records. And we'll just pay attention to the timing. Median. Median is 75, 74 milliseconds. And this is the previous version. The new version. Mark, I will give you 1 second to guess.
Well, so
you
this
didn't.
this one's the previous version.
Yeah, the new version will be not 75 milliseconds, but it's a lower level optimization.
So
I
is this
don't
going to
know.
be, is this the new version or the old version, what we're doing now?
Now we are doing the new version.
Okay, now we're doing the new one. I say 50. We've got many guesses. We've got 30, 22, 35.
56, 55.
What's 50th
Okay,
percent
so
hour? 56. Yeah.
almost 1.5 times faster. And it
Everyone
is,
was too optimistic on that one, I think.
can we optimize ClickHouse 10 times in every release? I would say yes. I would expect that. But not, I don't know, not in every query. Okay, and now we also have faster joins. And this optimization is pretty easy. And you're going to wonder why don't we have it earlier. So let's suppose we join a few subqueries, and subqueries have a column that we will then use. And it also has a column that is only used for filtering. So filters are obviously pushed down inside these subqueries. This is inner join. But in previous versions, we did not get rid of these columns as soon as they are used for filters. And they were still in the blocks for joining. And today in 25.12, we just optimize it better. I'm not going to show you a demo. It is pretty self-explanatory. Okay, now about even more interesting features. Something like top highlights of the Christmas release. And the first one is about our text index. You know that text index is experimental. It was experimental in the previous release, but now it's even more interesting. So just to remind, you can define an index in a table named with type text, and you can specify any type of tokenizer, like this is tokenizer for text messages. There is a special tokenizer for logs. You can specify any preprocessor. It is from the previous release 25.11. In this example, we will normalize UTF-8, so it will not confuse different ways of writing the same letters. It will lowercase, and then you can search for a token, search for a phrase that will be split by tokens, search for multiple tokens. And the new in 25.12, it is that it was rewritten almost entirely for a new optimized format. And this is already the third version of the format. It's okay. It was experimental feature, so the data format was not guaranteed for compatibility. And we had and used the chance to make it optimal before this feature is declared beta or production. And let me quickly show how fast it is. Because in this case, I was surprised to find it. I have two servers in ClickHouse Cloud, accessible by their connection names. We have the previous version and the new version. Both of them are labeled as 25.12, but the previous was a pre-release. And here it is the latest. And I have a table with logs. This table is fairly large, almost 10 billion records, and half a terabyte of compressed data, 2 terabytes of uncompressed data. Let's look what is the table. Text log inverted index. It's just a table with logs, server logs. And we can search inside the message. We have an index on message, index on query ID. And let's run some queries. First, I will run these queries without file system cache. So they will be called queries from S3, from object storage. And I will run at the same time on the old server and on the new server. Okay, let's run it. Here is the old server. It should use our index, and it works. 7, 8, 9 billion. It should, 15 seconds. And here it is on the new server, 2 seconds. It's a huge difference. It just does less number of requests to the object storage. Let's also run this query. We will search for a message committing part. And in this example, also called run first. Here it runs. Here it already finished in 1 second. And here it still runs 8 seconds on the old server, 1 second on the new server. So on the new server, you basically get real-time performance on these logs. It is almost instant. But now let's also take a look at the hot queries. I don't want to wait, so I'll run on the new server. 1 second, 0.1, 0.3. And here it did not finish. The new server already finished. So now you understand this optimization, this rewrite was definitely worth it. But even more, now we declare the text index as beta. It is no longer experimental. It means now we guarantee that the format will remain backward compatible. You can enable this index on production. It is still beta, so it might have some corner cases, but the format will guarantee it to be stable, and we expect it to be production ready in the next two releases. Okay, and another feature for profiling. This is probably for hardcore ClickHouse engineers. Because with this feature, on any ClickHouse server, you can tap on any function in the code. Just name a function and say what you want to do. Like you want to log this function, or you want to introduce some delays, or you can profile these functions inside a system table. And ClickHouse will automatically hot patch the binary and introduce these instrumentation points. And you probably don't need this feature on production. It's for me and for my colleagues. But anyway, if you're curious, we will have a presentation at FOSDEM 2026, the biggest open source European conference, about the mechanics, the implementation of these tracing capabilities. And we have a new join reordering algorithm named DP size. What is DP? Why is it named this way? And I will use the chance to ask Mark, Tyler, and if they will not guess correctly, I will also ask the next guest speaker. So Mark, Tyler.
I don't know. I expect the guest speaker will know.
Okay.
The chat says dynamic programming.
Okay. The chat wins. Yeah,
The chat is the winner.
Yeah, so it's like more exhaustive search of the optimal join order. Now this is not a new algorithm. It is used in Postgres, in many other databases. Now we have it in ClickHouse. Okay, and for data lakes, now you can specify order by, just like in merge tree tables, and it will be used during selects. And ClickHouse is one of a few systems that can utilize this global order of data parts. And for Delta Lake, we support reading of change data feed. All the changes like deletes, updates, you specify just minimum snapshot, maximum snapshot, and it will deliver the list of all the changes. Okay, now let's invite our Santa with a guest presentation about an amazing new development inside ClickHouse.
Thank you, sir. I'm David Wheeler. I'm a Postgres developer, mostly with extensions, and I want to talk to you about the extension we've been working on at ClickHouse. First, I want to spin up here a quick ClickHouse Docker image and get it loading some data here. I'm going to create a database called taxi and load the taxi data. Whoop. And first, we need to create the table, right? And then I'm going to start it importing. It's importing from S3 this data set for taxi data. So while it's doing that, let's talk about this extension. It's called PG ClickHouse. So the idea here is that we found at ClickHouse that the number 2 source of migrations to ClickHouse Cloud is Postgres. It's second only to open source ClickHouse, of course. And so a lot of people have existing Postgres queries. They start out with the database, they use their business on it, they start putting analytics data in it, they write analytics queries, and as their business grows, it starts to exceed what they can do. So, in Postgres itself. And so they look to move the analytics tables to ClickHouse in order to benefit from the performance there, but now they have to rewrite all the queries that they had previously written. So the idea here is that with PG ClickHouse, you can query ClickHouse directly from inside Postgres. And the idea we have here for these migration situations is for engineers to create a new schema within Postgres and import those ClickHouse tables that were moved over and therefore have the same format as they did in Postgres. And then they can point their existing queries at the new schema without having to change them in that were as before. But ClickHouse handles the execution, and what we're optimizing for with this extension is to push down as much of the workload as possible to ClickHouse itself. So let's see how it's doing here. Oh, I talked way too fast. It's at 45. Oh, Zoom is probably using up most of my bandwidth. I'm gonna let that go. I honestly thought it'd finish long before I finished talking. Does anybody want to sing a little song while we wait?
So for Postgres, is a sea shanty appropriate, or is
Absolutely.
hardcore music? Like I'm not entirely certain what song makes sense. Alexa actually has an amazing repository that uses ClickHouse and SQL to generate sort of very interesting MIDI music. It's not something that's sort of easily humanly consumable, but it is compelling.
Yeah, I don't know if we want to expose our friends here to that kind of torture.
Indeed.
I
So
listen to this. I listen to this music all the time, and it's not MIDI. It's like
that says a lot about you, Alexei. David, the NYC taxi data set,
Yeah.
would you describe that just really briefly while this imports?
Yeah, this is data. Actually, I'm not sure where it comes from. I borrowed this from the existing ClickHouse advanced tutorial, but it seems to be data of taxi rides in New York City in 2024, I want to say. Not actually sure. It's not a huge data set. It's about 1.9 million or almost 2 million rows, as I recall. So we're almost there, actually.
Yeah, it's a little over 3 billion. Taxi and
yeah,
forward vehicle hire trips that were in New York City since 2009.
Oh,
It's a
okay.
3 million row sample of that data set. Um, it's really interesting because the structure of that data, I think, is compelling in that it sort of feels inherently Postgres. But I think what you're going to describe is how that is also very much ClickHouse. So this is a sample of that broader 3 billion plus data set.
Yeah. All right. So I was just making sure we could query it here. So now I'm going to fire up a PG ClickHouse image. This is just the base Postgres image from Docker Hub with PG ClickHouse added to it. So I'm going to connect to it there. And the extension is already in there, so we can install it in this database, right? And then, let me move this up a little. What we do is we create a server here using the foreign data wrapper ClickHouse FDW, and I'm specifying it's using the binary driver to connect to ClickHouse on localhost host with the DB database name taxi. And then I need to create a user mapping. This is for passwords, right? You can actually put it into username and password. I have trust on locally here, so I'm not putting in a password. And this is for the current user, so that the current user will be able to automatically use these credentials for this service when they're logged in. Now I'm going to create a schema named taxi, and here's where the magic comes in. This statement here is going to import all the tables that are in the taxi database in ClickHouse into the taxi schema I just created here in Postgres. There is only one, which you can see here. It is named trips. But you can see here it's imported all the columns with the same basic structures it has in ClickHouse. And this is all mapped over, and it shows here that it's the table name trips using merge tree. And this is visible in Postgres itself. Now, let's just do a basic query. We're just going to count on it, and then you can see it returns close to 2 million. So that was pretty fast, right? In Postgres, when you do a select count from, it does a table scan. Here, it's just pushing it all down to ClickHouse, which we can see if we run explain on it. And it shows the first line is foreign scan. That means it's pushing all the execution out to the foreign table, in this case, the ClickHouse table. So let's consider the daily number of pickups per neighborhood, right? So now we're starting to use an aggregate. We're using sum here. This also runs quite quickly with the number of trips. Can explain. And again, it's a foreign scan. I can also do explain verbose, and it will show what the remote SQL actually was that executed in ClickHouse. Here's another one. We're going to calculate the length of each trip in minutes and then group the results by the trip length. So we're using a bunch of aggregate functions here: average, count, rounding, date part, etc. This all executes fine. And again, I could do explain, shows that it's just pushed down. So that means that these aggregate functions are executing on ClickHouse and simply returning the results. The count, these parts where it's, getting the date part out of things and rounding, all that's being pushed down to ClickHouse to execute. So let's talk joins for a minute. I'm going to create a dictionary, this foolish new feature Alexi talked about earlier. I'm using the ClickHouse raw query function, which allows me to just pass an arbitrary ClickHouse SQL function that then gets passed over. And I'm telling it to go to localhost in the database name taxi. And inside these dollar codings here, starting here and ending here, it's just all the ClickHouse SQL to do it. And it returns with no error. So now I'm going to, that's been created in the ClickHouse server, but not locally. So I'm going to import it again. I'm limiting it to the dictionary we just created. And we can see, let's see, make sure we can query it. So we're able to query it just like any other table. This is a dictionary. I want to be clear that any one of the engines that are used in ClickHouse, S3 or Parquet or whatever, as far as the foreign data wrapper is concerned, they're just tables in Postgres in ClickHouse that it queries, that it can map, and it's a straightforward connection. So now we can try a join. I don't remember the description for what this is, but basically we're just getting the borough and the number of trips. But we're joining to the taxi dictionary on the location ID here. So it's getting the total here, and there were the most in Manhattan, the second in Brooklyn. Again, I can explain. And you see that, again, the whole query is pushed down, including the join. So the execution has taken place entirely in ClickHouse, and it's just returning this short list of 6 rows for PG ClickHouse to show. Let's see, what does the actual query look like? It runs on ClickHouse. This is the actual query. It actually sends down. So you can see that it's doing the mapping and the joining. So that's PG ClickHouse. That's the basic idea. You're able to connect to ClickHouse and query stuff directly using, regular Postgres syntax that most folks have used with existing databases. So yeah, I hope you all enjoy that. You're muted, Alexi.
One question from the chat: does it work for inserts?
It does work for inserts, yes. The foreign data wrapper API in Postgres supports inserts, updates, and deletes, as well as selects. So you can do inserts and copy, and it'll work. There's also an API that'll support batch inserts, and I haven't implemented that yet. And that would make it so that copy turns into bigger blocks of data we're sending over to ClickHouse. Hope to get to that in the next couple months.
Yeah, and another question, if you do a query that joins Postgres and ClickHouse table, does it work?
It does work. That's something that we want to focus on next, is figuring out how to adjust the statistics and the estimation so that it's optimized for pushing as much execution down to ClickHouse as possible, and then bringing data back, and then you can join. Like if I had this taxi dictionary as a small table here in Postgres, it'd be nice if it just brought the data back, and then it just did the join on the results that brought back. I'm not sure it actually would do that. It might try to bring all the data back and then join and then do the aggregation. So that's something we're looking at optimizing as much as we can.
Thank you. Yeah,
My
it's a
pleasure.
nice feature because I always use ClickHouse, but if I will have to use Postgres, I will use it with ClickHouse using PG ClickHouse. Okay, and by the way, we have another feature for those who like Postgres and ClickHouse, and also can give a little bit of trust to AI. It is named ClickHouse Build. It's a tool that you point to your repository with your Postgres, with your code that uses Postgres. It will scan the repository and prepare a migration script. The migration script will create a ClickHouse database, set up click pipes that will migrate all the data into ClickHouse to accelerate your queries. And it will even edit the code base, and it will even test and apply tests for your code base. So if you want to give it a chance, clickhouse.build, a nice tool if you always wanted to migrate to ClickHouse but did not know where to start. Okay, and now we have about 1 minute for questions.
Yeah, let's have a look. I think you've answered most of them as you were going. Someone asked one for David. Can you do joins between both databases? I guess asking whether you can
Yes.
join Postgres to ClickHouse.
Yeah, it was covered.
Ah, cool.
Yes.
Okay, so we've done that one.
Thank you.
I think we did. There's none on YouTube, and there's no more I can see on Zoom. So maybe we're good. Maybe we've done everything.
Indeed,
Tyler, do you want to wrap
we've
it up?
answered them as we go along, which is impressive. It means that we have the same questions that the people watching did. It's the 19th of December in some places. It's the 18th of December in others. It's approaching the end of the year. Whether you celebrate a particular holiday at this time of the year or whether you don't, this is a time of the year where you get to spend some time with family, because technology companies largely slow down. This is a special release for us. Full text search, all the join updates, what we've done with PG ClickHouse, ClickHouse.build. It's a special time of year. If you have time, if you want to, play with ClickHouse. Let us know what's amazing. Let us know what's not amazing. And most importantly, share your favorite features with others. But above all that, enjoy your time with your friends and with your family. Thank you so much for being here today. Thank you, David, for joining us, for sharing what PG ClickHouse is up to. Mark, for giving us great insight into the estimation of query performance, and Alexei for compiling a presentation against what everyone has built. We look forward to seeing you in January. See you
And
soon.
start preparing your wishes for ClickHouse Features 2026.
Indeed, the roadmap will be up before too long, and we look forward to that conversation as well. That'll be a fun one in January.
Thank you.
Alexei, Germano, Barath, all those who